Okay, so today we're gonna do 3.2 properties of determinants. And then I did not mention determinant of a triangular matrix last time, so I want to cover that before we do that. So definition. So triangular matrices. Okay, so we have, I'm gonna just write down how matrix form. So in this case, lower triangular matrix. Lower looks like upper. So this is upper. Yeah, 0, 0, and diagonally some number, right? Yeah. And 0, and that. All right. Okay. So this is 0. Looks like upper. So if we have upper or lower triangular, then if we want to find the determinant, then we can just multiply of their diagonal numbers. All right. So upper, in that case, is a triangular matrix. Okay, so theta, determinant, a triangular matrix. So let A be upper or lower triangular. So we introduced upper, lower before, right? Triangular matrix. Just draw the triangle, right? With the numbers. So for instance, here, that's why it's upper, right? If we have that numbers there, then it's lower, right? Okay, lower triangular matrix. Then determinant of A is obtained by taking the product of entries on the main diagonal. Okay, so for instance, if we have A, one, 2, 3, 77, 0, 2, 6, 7.3, not point, 0, 0, 0, 0, 3, 33.7, 0, 0, 0, -1. Okay, we want to find the determinant of this matrix. Okay, then we should recognize this is upper triangle matrix. Then we just make a diagonal of those product, right? So we have 1, 2, 3, -1. What do you get?
-6.
Thank you very much. And also give a message. Thank you. Okay. So that's it. All right. Now, so we're gonna talk about properties of determinants. So we have definition, row operation. So we have a row operation. Let's bring up here again, definition. So we have a row operation from the previously. So we have a first one, switch to rows, right? Switch to rows. And secondly, multiply a row by a non-zero number. Okay, number 3. Replace a row by a multiple of another row added to itself, right? So those are row operation. Switch the row to rows, multiply a row by non-zero number, replacement, right? So we said the switch, interchange, multiply by scalar, replacement, right? Okay. Now, in this section, we are talking about determinants, right? So it's related with the row operation with the determinants. So let's take a look. Theorem 3.2.1, switching rows. So switch 2 rows here. Switching rows. Okay, so we have let A be n by n matrix and B be matrix which results from switching two rows of A, then determinant B equal to it's the same as a negative determinant of A. Okay, that's the switching rows. They have a switch 2 rows. Then B is the result from A. Then this be same as negative of a determinant of A. All right, so let's understand this one. We have the example. Let A equal to 1, 2, 3, 4. Okay. What is the determinant of A? We calculate it this way, right? So 4 minus 6, which is -2, right? Okay. Now, we have B equal to 3, 4, 1, 2, right? Okay, what can we see in that case? So we can see that they switch the row exchange. Good. So row exchange. So R1 exchange R2, we denote this way, right? So row exchange, switch the row, interchange rows, right? Okay, then we know that what's the determinant of B? Then we had the negative determinant of A. So negative determinant of A, that is negative. What's the determinant of A? Which is negative 2, which is positive 2, right? Okay, let's check that. Check it out. Check the answer, all right? Determinant of B. So we multiply this way, right? So 6 minus 4, what do you get?
2.
There you go. Good, thank you. It's 2. Good job. Okay, now we have multiplying a row by scalar. Okay, so we have let AB M by M matrix and let B be a matrix result from multiplying some row of A by a scalar K, then multiplying by scalar. So we have a determinant of B, which is the same as K determinant of A. All right. Okay, now let us do this one. Let A equal to 1, 2, 3, 4. Okay. I believe it's the same. 1, 2, 3, 4, right? Okay. So we knew that determinant of A, which is negative 2 from the previously, right? Okay, let's see. B equal to, we have 5, 10, 3, 4. All right, what can you see? We can see second row is the same, but then we can see that from matrix A to the B, we have scalar 5. Yeah. So determinant of B, which is K determinant of A. So what's the K in the case? Times 5, right? For the first row. To get 5 and 10, so 5. So determinant of A, which is negative 2, which is negative 10, right? You guys okay? All right, very good. So let's check that. check determinant of B. Okay, so that is, we multiply this way, so 5 times 4 minus 10 times 3. What do you get?
-10.
Negative 10. Thank you so much. So 5 times R1 to make okay, to make B. So 1 of B. Yeah. Okay. Now we have another one because the row operation has the 3 steps, right? 3 strategies. So let us do this. Theta 3.2.4, adding a multiple of a row to another row. Okay, so we have let A be n by n matrix, and let B be a matrix which result from adding a multiple of a row to another row. Then determinant of A is the same as the determinant of B. Okay, so this is row replacement, right? So in that case, since they have the same, let us talk about more this one. Yeah, same. Then we don't actually don't have to this one. Okay, so example, we understand this one first. So let A equal to 1, 2, 3, 4. We know this is determinant of A, which is -2. Okay, now let B equal to 1, 2, 5, 8. Okay, how did we get? So 1, 2, 1, 2 is the same. And how do we get 3, 4 to 5, 8?
Add 2 of row 2, 2 of row 1 to row 2.
Excellent. So if we have 2 row 1 plus row 2, yeah, to get row 2. So we call this as a replacement, right? So we have a scalar and add to another row. Okay, so then we knew that this is a determinant of A equal to determinant of B. So since we have a determinant A is -2, so does this one, right? So determinant A equal to determinant of B, which is negative. All right. Okay. So why we are doing this? Once again. So summarize. Summary of the properties. Okay, so we have interchange, right? Determinant of B, which is negative determinant of A, switchable interchange, right? And determinant of B equal to K, determinant of A, multiplied by scalar. And determinant of B equal to determinant of A, replacement. Okay, now we have let us do this one. Why we are doing this one? We're using these properties and find the determinant. So we have A equal to 1, -4, 2, -2, A, -9, and -1, 7, 0. Okay, so we want to make a upper triangular matrix. Create upper triangular matrix. And use the determinant properties and properties to find the determinant of it. How about that? Okay, so our goal is we want to make an upper triangular matrix for this one. And then we are using these properties. And at the end, we are using the product of diagonal numbers. Okay, so little complicate. Okay, we want to make a 0 in the case. So thank you, the message 2R1 plus R2 to get R2. So we have 0, 0, -5. Thank you very much. And we get Maybe we do at the same time because we're gonna use R1 again, right? So we want to make a 0 here.
Add R1 to R3.
Excellent. Thank you. So we have a 0, 3, 2. Okay, now we don't want 0 in the case because if we have 0, everything is 0, right? Then we do interchange. Okay, so look, this is a replacement, right? So if we have a replacement, since the same, we don't do any action. Switch the row, we put the negative sign. All right, so we switch rows, interchange, yes. So we have R2, R3, interchange. Then we put the negative, all right? So equivalent. So 1, -4, 2, and 0, 3, 2, and 0, 0, -5. Okay, so we done. This is upper triangular matrix. So determinant of A, which is, we count this negative. So how about -1? And then 1, 3, -5. Thank you very much, Says. So can you please calculate?
It's a 15.
15. Okay. Thank you very much. It's a 15. All right. So let us do one more about the scalar. So this one, a little bit different. A equal to 2, 2, -2, 3, 4, -4, and 2, -3, -5. Okay, so this one create reduced, no, not reduce row echelon form. It's a reduce row, no, row echelon form. Create RAF and upper triangular matrix, and use the determinant of properties to find determinant of it. Okay. All right. So we want to find, so basically determinant of it, right? We want to find determinant of it. Okay, we want to make one
So subtract row 3 from row 1. Or no, never mind. Divide it by half.
Yeah,
Or
1/2.
multiply by a
Multiply
half.
1/2. Okay, multiply by 1/2 to get 1/2. So this here will be 1, 1, -1. Thank you very much. Okay, so look, this is, we do the row operation, right? But then when we use determinant of a scalar, so this will be k, so multiply by scalar, right? So we are going to write down 2 there instead of 1/2. Can you see that? So this is a scalar, multiply by scalar, then we get that, right? Okay, now we have 3, 4, -4, 2, -3, -5. Okay, we want to make a 0 here.
Zero where?
0 here, sorry.
Multiply row 1 by 3, and subtract it.
R1 plus R2 to get R2, right? Okay, so 1, 1, -1, we have 2, and there will be 0, 1, -1, and then we want to make a 0 here. Row 1 again, so -2, row 1 plus row 3 to get row 3, right? Okay, so we have 0, -5, -3. Please correct me if I make a mistake. Okay, so we have that. All right, thank you for letting me know in during message. Okay. All right, so we want to make a 0. Oh, did I make a mistake? So we want to make a 0.
Which we add row 1 times 5.
Hold on 1 second. So we get 0, thank you, 5, row 2, row 3 to make row 3, right? So this will be 0, 0, -8. Is it okay? Okay, now determinant of A, then we are using this factor scalar, right? So 2, 2, so 2, and diagonal. So we have 1, 1, -8. Can you please calculate? So -16. And thank you very much for confirming. Okay. So that is the one. Yes, thank you very much. All right, so we have another determinant properties. So we have theta 3.2.5 determinant of a product. Okay, so we have let A and B is n by n matrix. Then we have a determinant of AB, which is the same as determinant of A and determinant of B. Okay, so let us do example. compare. So we will compare whether they are same. And determinant of A, determinant of B. For A equal to 1, 2, negative 3, 2. B equal to 3, 2, 4, 1. Okay, so we are going to multiply first, and we are finding determinant, right? So AB. Okay, so we multiply this way, right? So 1 times 3 plus 2 times 4. And second row, first column, so negative 3 times 3 plus 2 times 4. And that we get 1, 2 plus 2 times 1. And we get negative 3 times 4 plus, oh, I made a mistake now. Negative 3 times 2 plus 2 times 1. Please correct me if I make a mistake. So can you please calculate? Your turn. What do you get?
11, 4, -1, and -4.
Excellent. Thank you very much. Okay. Now we want to find out what is the determinant of the product. So we multiply this way. So 11 times -4 minus 4 times -1. Can you please calculate? It's -40. Thank you very much. Okay, now let us compare. We have A, and we want to know about the determinant of A, which is we multiply this way. So 2 minus 2 times -3. Can you please calculate determinant of B? Multiply this way.
-4.
It's a -4. Huh? You guys have different.
Oh, sorry, that's 8.
It's 8. And
-5.
-5. Excellent. Thank you very much. Okay, so we need to multiply two, right? So, oh, yeah, it's the same, right? So determinant AB, which is -40, which is the same as determinant of A, determinant of B, which is also -40, right? Okay. Now, determinant of transpose. Theta. (3.2.6) determinant of the transpose. Okay, so we have let A be a matrix where transpose of A is the transpose of A. Then this is very interesting. Determinant of transpose of A, which is the same as determinant of A. Okay, so let us do example. So we have let A equal to 2, 5, 4, 3, and find the transpose of determination. Okay, so we do inside first, right? So we are going to find the transpose of A first, and we're gonna find the determinant in that. So transpose. So transpose, we make a row to column since there's more than one. So 2, 5, 4, 3, right? Okay, now what is the determinant of transpose of A? So we multiply this way. So 2 times 3 minus 4 times 5. What do you get? It's negative 14.
Yeah.
Thank you very much. Okay, now, then we should know what is the determinant of A. So determinant of A. So we multiply this way. So 2 times 3 minus 5 times 4.
It's also negative.
Also negative 14. Thank you very much. Okay, then we can conclude the determinant of transpose A is the same as the determinant of A, right? All right. So this will be last one. So we have a theorem. 3.2.7. Determinant of the inverse. Okay, now let A be n by n matrix. Then A is invertible. If and only if, right? And only if determinant of A is not equal to 0. It follows that so we have a determinant of inverse of A. It's the same as 1 over determinant of A. Okay, so let us do this one. Example. Let A equal to 3624. This book is so nice. They give us 2 by 2. Okay, for each matrix, determine if it is invertible. If so, find the determinant of the inverse. Okay, so let's check that. Determinant of A. So we check that whether that is invertible. So we must find whether the determinant of A is not equal to 0, right? So I introduced it before, right? I did not say determinant, I said AD minus BC, right? So that's not equal to 0. So then the determinant of A is equal to, okay. Determinant of A, so we multiply this one, so 3 times 4 minus 6 times 2, what do you get? Thank you very much to your message. So
0.
0, thank you. So then we can conclude A is not invertible. Very good. Okay, let's check determinant of B. So we multiply this way, right? So it's 2 times 1 minus 3 times 5.
A negative 13.
So it's negative 13. Okay. That means since this is not equal to 0, B is invertible, right? Okay, B is invertible. If B is invertible, then we can have this one, right? So determinant of inverse. So that is determinant of inverse is the same as 1 over determinant of B, right? Okay, so that is 1 over determinant of B, which is negative 13. Yeah, so that is negative 1. Okay. Any question? Okay, thank you for coming.